Hi students, welcome to Civil Ed, an e-learning platform to engineering students. I am Professor Shivaprasad from Civil Ed team. In continuation of the video lectures on engineering mechanics, we are continuously working on to make students visualize things in the most possible easiest way. So, subscribe and keep updated with all new video lectures. In this video lecture, I shall present you the theory behind types of beams under equilibrium of non-concurrent force system. To begin with, I am happy to inform you all that today's presentation is just not a video lecture but a video lecture come notes, which is going to help you out with the way you are required to present yourselves in the written exams. Now, to understand the types of beams, the students are required to have knowledge on types of supports and support reactions. So you are kindly informed to view our module 2 lecture 5 video and then move on with the present video lecture. So these beams are classified based on the types of support. So that's what I said, you are required to have knowledge on types of supports to go ahead with types of beams. So let's see to how many number of types these beams are classified. So first one, we have the cantilever beam. Secondly, we have the simply supported beam. Third, we have one end hinged and other end on rollers. Next, we have overhanging beam. Fifth type, we have both ends hinged, and sixth type, it is propped cantilever, and last we have continuous beam. So if you observe here, all these beams are named after the way they are supported. So just understand support reactions, that is under types of support, and then move ahead with this types of beams video lecture. Let's begin with the first type, that is the cantilever beam. So a cantilever beam is one whose one end is fixed and other end is a free end. So let's try to draw the sketch for this. So a fixed end can be written diagrammatically in this way. Next, a beam is fixed to this fixed support. I'll name them as A and B. A is at the support end and B is the free end for the beam. Next, the support reactions that are coming into picture over here are the vertical reaction, that is VA, a horizontal reaction that I'll represent it as HA, and a moment, that is M at A. So if you recall that during support reactions we have explained these things clearly, that for a fixed support we have all the three reactions coming into picture, that is vertical, horizontal and moment reactions coming into picture. With this, let's continue to write few more points on cantilever beam. So a cantilever beam has three reactions at fixed end, that is VA, HA and MA. You can observe the same in the sketch. There is no reaction at the free end. Yes, there is no support at end B, that is the free end. So there is no support reaction at the free end. Next, three conditions of equilibrium are required to analyze the beam. Yes, there are three unknowns, that is VA, HA and MA for this type of beam, that is cantilever beam. And so you require all the three conditions of equilibrium to analyze the beam, that is to find the unknowns. Next, we can say this beam, that is cantilever beam, is statically determinate because we have three unknowns and there are three conditions of equilibrium, and we can easily solve this and analyze. Now let's move on to the next type of beam, that is a simply supported beam. A simply supported beam is one which rests with both ends on simple support. Okay, if you recall from the previous video lecture, A simple support looks somewhat like this, and simply supported beam rests with both ends with a simple support. So we can place the beam like this on both simple supports. Next, I'll name this A and B, and at A, what are the reactions? So a vertical reaction that we can represent it with VA, and another reaction at B, that is VB. So this is how a sketch for a simply supported beam, that is a free body diagram for a simply supported beam, looks like. Now let's continue to add on few points on simply supported beam. So this type of beam has one reaction component at each end. That's what we have seen. So end A is having one reaction component, and end B is having another reaction component. The reason is they are simple supports. Next, this beam resists only the forces that are normal to the beam axis. So let me explain you this sentence. So what is that? What do you mean by this? So this type of beam, that is the simply supported beam, rests on two simple supports which can resist only vertical loads. So if you have any inclined loads coming into picture, then this beam can slide away. So there is no connection between the simple support and the simply supported beam. So for that reason we say this beam resists only the forces that are normal to the beam axis, that is vertical loads only. Next, two equilibrium conditions are sufficient to analyze this beam. Yes, so there are two unknowns, and so two equilibrium conditions are sufficient to analyze the beam. Next, this beam is statically determinate because we have three conditions of equilibrium and only two unknowns. So we say this beam is statically determinate. Moving on with the third type of beam, that is one end hinged and other end on roller. So how to define this? One end of the beam connected by a hinge and other end rests on a roller support. That's what is this third type. As I told you before, so these types of beams are named after their supports, that is the way they are supported. So let's try to draw a sketch for this. So one end we will use a hinged support and another one is a roller support. The beam is placed over these two supports, that is the left side we have a hinged support and the right side we have a roller support, and we'll name this beam as A and B. So at point A, that is end A of the beam, we will have how many reactions? If you recall, two reactions, because it is a hinged support. So one is that vertical reaction, let's call it as VA, and another one is a horizontal reaction, HA. And coming to the end B of the beam, so it is a roller support. Roller support will have only one support reaction, so that we can call it as VB. Now let's comment the same by writing down few bullet points. So one reaction component at roller support, that is VB. So this support at B we are saying, and two reactions at hinged support VA and HA. So that's what we have shown in the sketch. Next, three equilibrium conditions are required to analyze this beam. So why? Because three unknowns. One hinged support will have two unknowns and one roller support will have another unknown. So altogether three unknowns, and so we require three equilibrium conditions to analyze this type of a beam. Next, this is statically determinate. The reason is number of equilibrium conditions equal to 3 and number of unknowns are also equal to 3 for this type of a beam. Moving on, let's look into the fourth type of beam, that is a overhanging beam. A overhanging beam is one which projects beyond the support. So let's put a sketch for that so that you will understand it in a better way. So I'll choose one type of support on left side and another type of support on the right side. So I'll place the beam over here, and let the left support be a hinged support, and of course the right support is a simple support. and I'll name that A, B and C. Now it's the time you need to concentrate here. We have named this beam as A, B and C. If you observe the portion BC, it is projecting beyond the support point B. So such a projection beyond the support is called a overhang. So due to this reason, we call this type of support as a overhanging beam. So one more thing you need to observe here, this type of beam is not named after the type of support. It's just named for the reason that it is projecting beyond the supports. So it is called a overhanging beam. This instead of a hinged support, I can have a simple support. Instead of a simple support at B, I can have a roller support, any other combinations. So just let's to our routine way, I'll draw the support reactions. So vertical reaction at A and horizontal reaction at A. Again, coming to point B, I have a vertical reaction only. That is, the reason is due to it is a simple support. Now adding on to this, what can we say? So a overhang may be on one side of the beam or on both the sides. So that's what this in the example sketch what we have drawn, the overhang is only on one side, that is on the side BC. BC is overhang. Again, any type, another type we can say the end A is also overhang. So such a case we can say both sides of the beam are overhang. Moving on to the fifth type of beam, that is both ends hinged. So both ends hinged, as the type name itself suggests, we have both the ends of the beam are connected to hinges, that is hinged supports. So let's draw the sketch for this. So I'll choose two supports over which a beam is placed, and both these ends are connected by means of hinges. You can observe that in the sketch over there. So next, drawing the free body diagram for this type of beam. Let's name them A and B. So at A we have a support reaction VA and a horizontal reaction HA. The reason is due to that it is a hinged support. We have two support reactions coming into picture. Same case on the side B also, that is VB and HB are the support reactions at the end B. So next we have the total reaction components are 4. So 2 on each end, that's what is the thing. Next, this beam is statically indeterminate. Why? Because we have 4 unknowns. Number of conditions of equilibrium available are only 3, and that is this type of beam is exceeding by one number, that is number of unknowns are exceeding by one number. So we say this type of a beam is statically indeterminate. Moving on to the sixth type of beam, that is a propped cantilever. So a propped cantilever is one in which one end of the beam is fixed and other end is simply supported or is on a roller support. So I'll choose one end of the propped cantilever as a fixed and other end I will choose a simple support. So such an arrangement, a cantilever with a simple support at its free end, can be called as a propped cantilever. Now the support reactions at the end A, that is the fixed end, we have a vertical reaction VA, a horizontal reaction HA and a moment reaction MA. So coming to point B, we have one vertical reaction component, that is VB, because it is a simple support. So adding on to this, the total number of reaction components are 4 as shown in figure. So 3 reaction components at the fixed end A and 1 reaction component at the simple support end, that is VB. So there are, just because there are 4 reaction components, that is 4 unknowns are there, we can call this propped cantilever as a statically indeterminate beam. Moving on to the last type of beam, that is the 7th type, continuous beam. So a continuous beam is one in which the beam supported on 3 or more number of supports. Okay, so the criteria over here for a continuous beam is that there are minimum 3 supports, or it may have more number of supports also. So to understand it, I'll take up 3 different supports over here, above which we shall place the beam, and I'll name the beam as A, B, C at the support points. At point A, we have a hinged type of support, and B is a simple support, and C is resting over a roller support. So all these three supports continuously are placed based on the span length. If the span length is exceeding more, the beam requires more number of supports. So for that reason we have more number of supports for a continuous beam. Next, the routine way, I'll just try to draw the support reactions for this. At point A, I'll have 2 reactions, that is vertical reaction VA, horizontal reaction HA. Moving on to point B, I'll have 1 vertical reaction VB because it is a simple support. Next, moving to point C, I'll have again 1 reaction component, that is VC, because it is a roller support. So if you want to understand better about how to take these support reactions for different kinds of supports, you please have to view our previous video lecture on the types of supports. Next, adding on to continuous beam, 3 or more reaction components exists for a continuous beam. So that means to say, in the example what we have considered a combination of supports, hinged support, simple support and roller support, we got 4 unknown reaction components. But if you choose all the 3 points as simple support, you may get only 3 reaction components, that is VA, VB, VC, like that. So in this combination of example we got 4. So you can say if you have 3 unknowns only, then that continuous beam may be statically determinate. But if you have more than 3 number of unknowns, that continuous beam will be statically indeterminate. With this, we have come to the end of this video presentation. So for further video lectures on engineering mechanics, kindly subscribe and keep updated for more video lectures, and share with your friends. In the next video lecture, you may expect types of loading, and that would be of a lecture notes type, the same way we have done in today's presentation. Thank you.